Hi, tonight we're going to be looking at the definition of a function. So, a function is a relation that takes some numbers x, and we call these the input, and they relate them to a set of outputs, f of x. This can also be called a mapping. So we can say that some function maps some input to some other output. So we can call a function is also known as a mapping. A function can either be 1 to 1 or many to 1. So this would be a 1-to-1 function, or you could have two numbers that go to one output. That would be a many-to-one function. So let's consider an example. So let's say we've got the function x is mapped onto x plus 2, where x belongs to the set of real numbers. Now, for functions, it's good to go over and remind yourself of some of the set notation. So this would be belongs to, or is an element of, and r means all real numbers. So let's see what this looks like. So we've got f of x, and we have our x-axis. Well, it's meant to be a 2. There we go. So this would go through here. So this is line y equals x plus 2. This is a 1-to-1 function, because for every input x, there is a unique output, f of x. So we can write f, then we have a colon, x, then this kind of arrow here, x plus 2, where x is belonging to the real numbers. Or we can write f of x, let's do a line here for or f of x equals x plus 2 for, I'm going to write a space for x belonging to the real numbers. We don't need that bracket. What this means, what this here means, the function f is such that x is mapped to x plus 2, or f maps x to x plus 2. F of x is the output, so f of x is the output of the function f, and the input value is x. So we'd have x here, and you'd have f of x over here. For example, if we had f5, we would have x plus 2, 5 plus 2 is going to be 7. Let's consider another example. Oops. Let's consider the function x such as is mapped to x squared, where x belongs to all real numbers. Now this is going to be a many to one function. Let's do a sketch of it and we'll show you what that means, what that looks like. So we've got our inputs x, we've got f of x, and this is y equals x squared. So say if we've got a value here, let's say that was 2 here. 2 squared is going to be 4. But say we had minus 2. Minus 2 squared is also going to be 4. So we've got two values of x, but they both have the same output value. So a many to one function has one output value, so there's our one output value for each input value, but each output value can have more than one input value. So you can have two different values, so we could have this is 2, this is minus 2, and they're both going to be mapped onto the same output. And that would be 4. Now we can write this as f, the function f is such that x is mapped to f of x. The function f such as x is mapped to x squared for x member of real numbers, f of x, or f of x equals x squared for x belongs to real numbers. Now, you might be thinking, I'm labouring the point by, for each time, specifying what x belongs to. For functions, this is really important. It's really important that you define your domain, you define what x is, define what x belongs to. Especially as you go more advanced, you could be doing functions that belong to a different set of numbers. So it's really important we know what we're dealing with. So again, this reads, the function f is such that x is mapped to x squared, or f maps to x squared. Now we're going to look at another graph. We're going to look at this one. We're going to look at y squared equals x. Now this is going to look, this is x, this is y. This looks like this. Now, y squared equals x. Now we can see that the input value, so their inputs, so we've got a number here. This input value has two outputs. Oh, where the arrow went. So for one input, we can have two outputs. So let's say this is 4. This can be plus 2 or minus 2. Therefore, this is not a function. A function has to be either 1 to 1 or many to 1, but this is 1 to many. This is 1 to many. And that's not a function. Now, a couple more definitions. The set of input values for a function is called the domain. Of the function. So it's really important to remember that the domain is the input values. When we define a function, we always define the domain. And lastly, the set of output values for a function is called the range. Also known as the co-domain of the function. So the range or codomain are the output values and the domain are the input values. Now let's look at an example. So we're going to look at this function. We're going to look at f of x equal to 5 minus 2x for x belonging to the real numbers, and the domain is minus 4 less than or equal to x less than or equal to 5. So this could be a question that you'd be asked. Firstly, what is the domain of the function? This is not a trick question. The domain is minus 4 less than or equal to x less than or equal to 5. Sketch the graph of the function. Now, when you say sketch the graph, okay, this does not mean you're doing a beautiful to scale picture of the graph. It means a sketch. It's not perfect, but you need to have the key features on it and the right shape. So if the gradient's positive or negative, so you're looking for the right shape and the key features. So when we're doing it with a function, we're going to look at the maximum and minimum values. So let's find out firstly what f of minus 4 would be. So 5 minus 2 times minus 4 equals 5 minus, that's going to be minus 8, so it's going to be plus 8, which is going to be 13. And then we're going to have f of 5, so 5 minus 2 times 5 will be 5 minus 10, which is going to be minus 5. Now this is a straight line graph because there's no quadratic part to it, so we're going to have, I need this to be a wee bit longer. So f of minus 4, x is minus 4, so it's going to be down here. and that's going to be way up here, it's 13, so this, and we'll write the coordinates here, so it's going to be minus 4, 13, and then this is going to be 5 and minus 5. So 5 minus 5, and it'll go down there. Use a ruler, and then we're going to write down the domain. Now, let's think about it. The range was the values of x. So here was the range. The domain. So the domain's the input values. Okay. Now the range is the output values, or what we get for f of x, or what we'd have along the y-axis. So this must be the range. Okay, so the domain is, so what is our minimum value on the range? It's minus 5. Is less than or equal to f of x, so it's the range, and the maximum value we have here is 13, less than or equal to 13. So for this function in this domain, the range is this, and within this domain and this range, this is what the function looks like, but it's a straight line, not a squiggly line. Use a ruler. Let's look at another example. So the function can't spell, f is defined by f of x to x minus 3 squared plus 8 for minus 1 less than or equal to x less than or equal to 9. So we want to sketch the graph and find the range. So let's look at this. So we've got f of x equals to x minus 3 squared plus 8. Now, it's a quadratic. So when you see a quadratic, ask yourself, what is the minimum or maximum value? So for this, if this is 0, this is squared, this part here is squared, so the smallest value must be when this is 0, when we get rid of this. So when x minus 3 equals 0, that's when x equals 3. And f of x then would equal 8. So this is the minimum point. It's going to be 3, 8. Now again, we're going to look at the domain, the minimum and maximum values of the function within this domain. So let's look at where f of minus 1. So minus 1 minus 3 squared plus 8 is going to be minus 4 squared plus 8, which is 16, plus 8, which will be 24. And then we've got f of, what was the other domain? 9. So it's going to be 9 minus 3 squared plus 8, which is going to be 9 minus 3 is 6 squared, 26, 36, add 8, which will be 44. So this is going to be minus 1, 24 and 9, 44. And we've got the minimum here. So let's sketch this. So we've got -1, 24, this here. We've got 3, 8, that there. And then we've got 9, 44 up here. So here we've got -1, 24, we've got 9, 44, and we've got 3, 8. Now this was our domain, and our range is here. So the range is the minimum value, so the minimum value is going to be 8, so it's not 24, it's the minimum value of the shape of the function within that domain. It's going to be 8 less than or equal to f of x less than or equal to, now the maximum value is 44. So I hope that helps.